Okay, so today we're going to talk about HAZOP because HAZOP is one of the most important tools as an engineer because no matter what industry you go into, definitely if let's say they are an established industry, they will want to use HAZOP for their process safety analysis. So and HAZOPs, there's no right or wrong answer to do HAZOP, but it's just how should I put it? It's just a set of tools for us to see how do we use them. So if you refer to my notes earlier, I did talk about their sets of like, let me share the other screen. Okay, hold on a second. So if I were to share, because this share screen is a bit, um, so if you, are you looking at the HAZOP's share screen guide words?
No, miss.
Okay, you're not looking at that. Hold on. Let's see if I put this as share. How about now?
Yes.
Okay, so this one is the previous slides. I think 2 or 3 weeks ago that I put it up. So HAZOPs, we always use guide words, meaning we talk about like, for example, process flow. Then we look at is like, is that no flow? Is that higher flow? Is that lower flow? And then we look at like what could cause a higher flow or lower flow, or what could cause if there's no flow at all. So from there, then we develop into like what could go wrong, and the actions that we always put at last is what are the possible causes, and the actions taken in here. If you are looking at this, is always talking about how do we want to resolve the actions here. And also another thing is how do you want to reduce the consequences? So there are two type of actions. One is preventive, to prevent the possible causes or to prevent what things that could go wrong, or also to reduce what we call as a detections method, to reduce the consequences, to reduce the impact of the consequences. So if we are to look at today's tutorial, I need to share back the tutorial again. Okay, hold on. Yeah, where am I? Here. So are you looking at the tutorial now?
Yes, miss.
Okay, good. So the tutorial here is with the first questions like we talk about like the heat exchanger is to use to heat up flammable volatile solvent in this picture. So you can see over here, if I were to draw, let's see if I can draw. Okay. So, okay. So this is the solvent. And we are to talk about heating up this solvent. And it is said that it is flammable, it is volatile, meaning if we overheat it, this might cause runaway reactions. This might cause build up pressures and then an explosion. So if you want to do a heads up for this case, which one do we select as the study note? You want to select the steam or do you want to select the stream, the volatile solvent? Which one, class?
Uh, is steam okay?
You can select steam. You can also select solvent. There's no wrong answer or right answer which streams that you select because steam itself will bring you to a different scenario and then the solvent itself will bring you to a different scenario. That's what we are going to do today. So if you look at the this meeting chat here, I actually post up a link for you to go to this I post it again in case any of you didn't get it. In the chat itself, there's a link. So go to the link. So now we have, okay, so what I will do is I will share the link now. I will share screen the link. So over here in the link itself, you can see there's a study notes. So just now we say, one of us say if you want to choose study note STEAM as the study note. So let me put this STEAM as the study note. And then what we are going to do is we are going to have another page called the volatile solvent. Okay, so this is the solvent stream.
Miss, are you sharing the page now? Because we can't see anything.
Oh, okay. Can you go to the Google spreadsheet?
Oh, okay. Yes, yes.
Yeah, straight away we can talk from there looking at the Google spreadsheet so you don't have to look at my screen.
Okay.
Would that be easy? Because I see quite a number of you are there. So what we can do is I want you to separate into different groups. So now we have this the first what's that called? The first sheet is on and then the second one is on the volatile solvent. So you have the process parameters that you can work with, like flow rate, temperature, pressure. And then the next thing is what I'm going to put in is the keywords. Yeah. So keywords for both page. And then also, then we look at the possible causes, possible consequences, okay, and also the action, and also PIC, who is going to in charge for that. So I want you to break into groups. One group's working on STEAM itself, another group's working on the solvent. So to make life easy, because here since we have two groups, one from mechanical engineering, one from chemical engineering. So can I have the mechanical engineering students working on the STEAM? And then the chemical engineering students working on the solvent stream itself. Yeah, we just
Okay.
split out in groups and then you start to fill up this page because everyone can work from it. So then we can have a discussion on like why you choose certain things that you choose here. You start filling it up, yes. I gave you all like maybe now it's 2:45. We will start discussions about 3 o'clock. So start filling it up. In fact, if you all want, you can just turn on your mic to start your discussion as well. I have just shared screen on the keyword so that you can refer to it. And this is the streamline keywords that you can use for. Like for if you look at it, you can see like if I'm to look at this streamline, the process line itself, the flow, temperature, pressures, and what are the keywords that I can use.
Hello, Miss.
Yes, yes, I'm hearing.
Miss, from the thing you shared, what does state means?
Okay, let me take a look.
The one you shared was the...
the status of the suppose, like for example, it's supposed to be liquid, but it could be something like in solid form, solidify, or it becomes it's changed from one state to another, meaning like it's a like the as well as is like we are expecting this to be a gas flow. However, it also comes as well as with liquid flow. So what is the impact? What will happen? Or
Okay.
if let's say it's supposed to change state within during the cool down from liquid to during the cool down from steam to gases to liquid, but it changed faster than or it changed lower than. So what would the impact be?
Oh, okay. Okay. Thank
Yeah.
you, Miss. Yeah.
Are we ready to discuss? Let me see. It felt so weird to conduct this online tutorial because normally I'm so used to see your write on the whiteboard. Okay, so the steam seems doing good, but how come the solvent is really slow? How many of you in here for the CE student? Because I see like only one person's typing. Done yet? I can see there are some very good one coming up. Okay. Sorry, may I ask, why is there the RPM here? Motor malfunctions. Oh, for the steam. Okay, okay. Let me see. Okay, look like we have almost done. That's a very nice one. Are we ready to share? Okay, I think we can start talking about this one. So, anyone wants to present, like, when you talk about temperatures, why do you say this, and etc. Can I have some volunteer who did the temperature to share with all of us, like, what make you think that this is happening, and what else can we add on?
Okay, hi Miss.
Hi.
Yes. Okay. So for temperature, if under the keywords of no, where there's the situation where there is assuming there is no steam or the steam temperature is negligible. So in a system like this, we consider that is not possible. Therefore, is no possible consequences, and therefore is no action to be taken.
Okay, can I throw in some challenging words here? So,
Yeah.
what if the possibility is that the sensor is faulty?
If the
That's
sensor
why you
is okay.
that's where you get no reading. There's no temperature. It can be that one though.
Yeah, then the possible consequences would be probably like people who operators of the machine might incur injury due to unknowing of the exact temperature of
Yes.
of the system. Yeah.
So that is where you see everything is possible, even though when we say there's no temperature, but it could be the sensor faulty. And when we have sensor faulty means that is a possibility of injuries due to unknown heated piping.
Yes.
Yep, that's a serious one. From no possibly no consequences to the potential injuries.
Yes.
So
So
that in that case, yep.
then the action to be taken for that is like you need to bring in the required follow the proper safety procedures that probably the company has in place for replacement of sensors. Or get the proper third party who are authorized by government or proper or officials safety authorities to come and replace it lah, so that it is a correct job to be done. That is for prevention, I guess. For detection, I think like probably if you see to detect whether they should probably have like a backup sensor lah, so that if one sensor is faulty, then okay, the other sensor detects, oh, that sensor is faulty, or the other sensor can not only detect sensor faulty, you can also be a backup temperature reading sensor like that.
Changeable. Okay. I'm typing as you said.
Sorry.
It's okay. Which is good because this is where you can see how we build on HAZOP. Because sometimes we may look at it like, hey, that is not possible. But if you look at from the engineering point of view, when we realize, hey, there is no temperature reading, immediately we know that, okay, something's wrong with either the sensor, it can be sensor faulty, or it can be the display unit faulty or something. Yeah. So, and then we also know that without this sensor or without the display, it could lead to quite a bad consequences because injuries is something like we call level, like if let's say level 0 or level 1 to level 10 hazards, where level 10 is really like death or something really bad. This is around level 7 or level 8 already because of injuries, because of burn. Yeah, you all get that now?
Yeah. Yes, miss.
Yes. Okay, so what about low temperature?
So when the temperature of steam is low, possible causes probably the incoming fluid or substance flowing in is low temperature. And then we concluded that is no major or significant effects if the temperature is low. So therefore, there is no necessary action to be taken.
Hey, let's look back at our, okay, and then we look back at our questions. Hold on, you need to give me a bit of time because this sharing windows is not as user friendly. So you see this now, can you see my screen? Back to the questions. Yeah. So
Yes.
if you look at the steam here, this steam coming in is to heat up the solvent. So when there is no temperature or the temperature is low, so let me write low temperature. So what happened means, it means that this one cannot be heated up. No heating. The impact will be the next process.
Okay. Yeah, makes
So
sense. Yes.
yeah, so we can't say that there's no impact because the impact is not the steam itself, but the impact is your next process. And again, then your next process, your production's yield down. Because I believe most of you have done your internship. In industry, they love to use the word yield, the production yield.
Yeah.
What is the yield today? So the moment we don't get the correct parameter up, then it's yield down. Yield down is a bad juju thingy. Yeah. So
Yes.
okay, so in that case, we may want to go back and update this one as well.
Okay.
Yeah. You now you get why I want to do an online discussion because from all the HAZOP analysis that you sent to me previously, I noticed that the thought process is not going deep enough. It's like as an engineer, sometimes we have to see things like 3 or 4 steps lower than that. Like, okay, now we say there's no temperature or there's low temperature coming in. Temperature means by on the steam itself, no issue. There's no significant impact on the system, on the steam system. It will not cause anyone to get injured because of low steam temperature. But then we look at what is the impact of that low temperatures to the next process, or has it done what it intends to do? Because if let's say I want to steam at 100 degrees Celsius, and then now I only have water coming in at 50 degrees Celsius. And if let's say I say there's no significant impact, means I actually don't need the 100 degrees Celsius. Then why do I run a pipe that is at 100 degrees Celsius? So the moment we realize, and when we do HAZOPs, we may realize something like that, then say, hey, we actually don't need 100. We only need like 70. That's where you can actually put in and say, oh, okay, let's take a look at this. We are going to reduce the incoming water temperature from 100 degrees steam to 70 degrees, because 70 degrees is safer than 100 degrees. That's where we call process improvement. You get what I mean here? You get the differences in here? So let me screen on the HAZOP. Okay. Okay, so there's no significant difference, but then there is a reduction of heating up.
The
What is it?
solvent.
Solvent. What is that? The reductions of solvent temperature. At potential yield loss. That is a different consequences now, because from no significant effects that may be like 0 impact hazards to now potential yield loss. Oh, I have a spelling mistake here. How to spell you?
YIELD.
Yeah, now that's correct. Okay, so thank you. So now we see that, okay, there's a yield loss, means the impact is huge. The impact is no longer 0. Now maybe it's at 5 or 6 because you can't get your yield. Yeah, so then you need to take actions. You can't just say, I don't want to take any action here. So what sort of actions do you plan to take in this case?
Probably have a sensor.
What else?
Um,
So sensor is a good one here. Sensor to for temperature range detection. Okay.
Probably regular checkup on the incoming temperature.
Well, if you have a sensor, you don't need to regular checkup anymore. So
Besides other, okay.
yeah. So if let's say you have this one, and what are you going to do with the informations to know that, hey, I have a low incoming temperatures? What do you want to check?
We will check steam station. Oh.
Yeah, you check your process
Okay.
before that. See what happens, what went wrong.
Oh, okay. Yeah, I get it. You bring it back to steam before entering solvent, right?
Yes.
Yeah. Okay. Yeah.
Yes. So that is how. That is why when we finish one HAZOP for an industrial plant, it can easily go to like a reports that is like as thick as a thesis or even thicker than a thesis, because all these things link back. And so when you go back to steam station, so the next thing is like, what are you going to check? That will be a totally new study note on the steam station, like the steam productions or the steam former or something. Then you look at, okay, what could cause this fluid that outputs at a low temperature output?
Okay.
Make sense?
Yes.
Okay, good. Now that I see that, Okay, so the last one, you have high temperature coming in. So incoming and yes, what is this?
So if it's too high temperature, the whole system might overheat,
Mhm.
and high temperature causes pressure to increase due to greater fluid temperature than the cooling water itself.
Okay, can I challenge this a little bit?
Sure.
Hey, hey, we talk about steam. What is the temperature maximum steam can go to?
uh, 100,
Aha,
100 is the boiling point of water.
yes.
Yes.
Are we talking about super saturated or superheated steam here?
Superheated, I think.
Okay, if let's say superheated means the pipes will not be because if let's say it's just a normal steam pipes, it will not be able to cater for superheated steam.
Uh-huh.
The pipe itself will before we build up to that pressure, because when we talk about superheated, another thing is that we have to talk about the pressure that causes it to build up to that temperature, because go back to the ideal laws. I'm sorry because ME sometimes you may have forgotten about the some of the basic chemistry, ideal law gas, the ideal gas law, sorry, where PV equals to nRT. So when we have an increase of P, then we can
Yeah.
actually allow the temperatures go beyond 100 degrees Celsius. But in order for us to do that, the pipes must be able to withstand higher pressure.
Mm-hmm.
So, but then if let's say our pressures, our pipe is not designed to do that, before we go there, the pipes already burst.
True.
So, in another word, in normal system, it is almost impossible for us to have higher temperature of steam.
Okay.
You get what I mean here?
Yeah.
Yeah. So this is where that's why during hands-on there's lots of things that we can learn, that things that we have not thought about previously. Yeah. So in this case, the third one, if let's say I'm going to put this one as 1.1, 1.2, 1.3, 1.3, it can be applicable. It can be completely non-applicable depending on your system. So what you can do here, if I were you, I would just put an asterisk here.
Okay.
Only possible if pipe is designed for high pressure. You can put that because you have no
Okay.
idea. Because as an engineer, sometimes we are not sure what the designer has put that in. Maybe they have put this in. They have already designed a high pressure pipes and we didn't know about that, or maybe it is not. So if let's say it is not, that means there is not possible to have an incoming of a temperature of the steam that is higher than 100 degrees Celsius to the system. Yeah. So this one we can put it this way, no problem. And even in exam or in the futures when we start to work, trust me, this is what we are going to do as an engineer. There's a lot of hazard analysis ongoing if you work in process. Yeah. So this is yeah. The rest seems okay. Okay, so now pressure. Do we have someone else want to present? If not, it felt like this is like one-to-one tutorial. If not, I don't mind you presenting. Shall we?
I can suggest my friend Sam. Miss, he
Okay,
also would like
please,
to present because we did
please,
together.
please. So I have 2.1 here. Yes.
No pressure. Okay, so next process parameter will be pressure, of which can be divided into two cases, obviously low pressure and high pressure. For the low pressure, one possible cause would of low pressure would be due to the control valve malfunctioning.
Mhm.
Basically, the valve unable to control the pressure of the
Mhm.
fluid flowing in,
Mhm.
and
Mhm. Mhm.
causing as probably the valve gets jammed for and not able to allow maximum flow or the
Mhm.
ideal amount of flow, causing low pressure.
Yeah, so you may want to write them down. Possible blockage, or the accidental turning, what's that called? Wrong setting.
Uh,
Wrong setting of the valve because it's a control valve. See,
yeah,
wrong setting. Yeah. So you may want to write, because the more you write it down, the more information you put that in, the more you know how to take action, because all this will link back. Yeah. Okay. So what are the possible consequences?
As you mentioned earlier, would be the low output, or rather low yield, I guess.
Low yield. Yes, that would be definitely there.
Uh,
Okay. Other than that, I think it's pretty just about you. Okay. So regular maintenance. And what else? Possible blockage maintenance can clear that. What about wrong setting?
Perhaps come up with SOP, or like a manual, or something like a simple check. No, would you say checklist, or some instructions that is posted near the valve control panel, instruction manual lah, for the operators to follow exactly what needs to be done.
Yeah, I actually like that. SOP, SOC, the checklist inspections, the SOC, the standard operating conditions, like what the condition should be.
Yeah.
Yeah, that's a good one.
Okay.
Okay, so the next one. Anything else you want to add for this one?
Yeah, that's all for now, I guess.
Okay, so what about high pressure?
For high pressure, I guess we can use back the control valve setting, or I think we can add some more
Okay,
things.
wrong setting is definitely one of them. Any other things that you can think of?
High pressure.
Or any other people in this group? We have like 11 or 12 of us here. Any other things that can cause high pressure? So control valve, I think it's not control valve malfunction. This one should be the pressure regulator malfunction.
High pressure.
Yeah, that will cause this. Wrong setting. What else that can possibly cause it? So if we trace back to the steam reformer, anything that's from there that can possibly cause a high pressure?
Possibly a build up of pressure in the steam station, maybe.
Yeah, of pressure in the steam station or process prior to this heat exchanger. That's a good one. Okay, rupture in tank.
Ramesh,
Yes.
is clogging another?
Yes, flogging. Yes. You know one thing about this hazard analysis, so far, for all the classes that I have taught, only ME students will tell me that is a possible of pipe flogging because of the modules that you have taken before. That's the biggest differences between CE and ME when it comes to hazard analysis. That is why I wanted the two groups to be in one session so that we can see different idea. Yeah, because I believe you have taken advanced fluid mechanics, something like that. That talks about all these potential pipes, build up in the pipes, etc. So that's a good
Is
one.
it flogging or clogging?
Logging, what's that?
Is it flogging or clogging?
Clogging.
C, right? Clogging. Right?
Clogging.
Yeah, clogging. Yeah.
Okay. So what's the possible consequences? Rupture in tank. Beside that, hello,
Explosion, maybe?
explosion
Okay,
potential. That's the same category.
yeah, I guess.
Okay. Anything else? When we have high pressure, the next thing is what?
The yield may be damaged due to
In
high pressure compressing the solvent to the not required level, something like that.
Mm, what about? Yes, there's the potentials in that because if we have higher pressure, means we are forcing the liquid. So now we go back to the chemistry. So we are forcing the liquids to get out of the system faster. So meaning higher potential higher hey, heat exchange to the product stream. Yeah. So meaning, in other words, higher temperature for product stream. Is that possible?
Yeah.
Yeah. Okay. So now this one, beside regular maintenance, we need to do something. So the first one I can remember, I can think of is we have talked about this and in chapter 2 or chapter 3, after chapter 3, relief system. Remember, we need to put in relief system at the incoming of the hot stream and also at the outgoing of the cold stream, because that's where the pressure changes. So when there's too much of pressures before it ruptures, not the rupture in tanks, but rupture in pipes, because this is piping. So we need a relief system. What else?
Yes, emergency shutdown can.
Oh, that's can emergency shutdown system. Anything else? Hello. Don't be too quiet. Anything else? Yeah.
That's all I can think of. Yes.
Okay. Yeah, I think basically that's about it for higher pressures that what we can do. Okay, so the next one, flow rate. Who wants to talk about this one? Anyone? Hello? Come on. This is an interesting one because I see a reverse flow rate. Come on, someone present it, please. Anyone? Just know who did this? Can we have the persons to present? Am I talking to myself?
Okay. No.
Okay,
Okay.
thank you.
Yeah.
Good.
So if the flow rate is fast, that means the valve controlling it may have an issue.
Mm-hmm.
One of possible causes, probably no major or significant effects on the system.
Mhm.
However, it's better to prepare maintenance checklist so that there's a regular checkup on the flow rate of the whole of the fluid in the system.
Heat exchange. The no major effects on the system, but there's a higher heat exchange to the other stream because it's a heat exchanger.
Yeah,
So
yeah,
meaning that
Morgan put that in. Yeah, I agree.
okay, so this one can slow.
Slow, I think that is probably the thermocoupler sensor malfunction.
Okay.
So there is slower removal of excess heat, which in other words is a slower rate of heat exchange. Therefore, probably causing gradual increase in temperature.
Okay.
And then yeah, these same actions are scheduled recalibration or
Mhm.
scheduled maintenance check.
Oh, that's a good one. What about the reverse flow?
Reverse flow back pressure
Aha.
may occur, resulting in backflow.
Aha.
This probably will cause reactor temperature to increase, possible runaway. Action to resolve this is to ensure that the check valve is present to regulate the flow.
So when you say reverse flow rate of the steam, what could cause this back pressure?
Back pressure, probably some type along the flow system. Probably there is a there is a possible blockage or crack that is causing back pressure.
Mhm. Okay, there's a possibility there. That's a good one. So no product produced. That's no, sorry, the reactor temperature increase. To which reactor? Or are you talking about the steam? Uh, yes, I think I hear someone, but I lost that person.
Sorry, miss.
So reactor temperature. I don't think it's reactor. It's more of the steam
Yeah, steam
station.
temperature. Yeah.
Yeah, steam station's temperature increase, possible runaway means you push it back in. Okay. It's not just temperature, the pressure will increase as well.
Yeah.
Okay, check valve to regulate flow. In fact you can actually put in a one-way check valve. Yeah, so meaning there's no way that back pressures can push it back. And in that case, this will also lead to the other one. You need a relief system in piping, in the pipe. So now you can see up here we call for one relief system. And down here we call for a second relief system, meaning these pipes you must, in the steam pipe is a must to have your relief valves in there, in the pipe. Just you put on the pipe so that you can actually one stone that kill two birds here, to ensure that there will be no runaway system. Okay, that's a very good one. RPM, this is an interesting one. What is this RPM for?
Actually, I'm not so sure. So what got RPM?
You put it
I don't understand the RPM, but
okay, but who put it there?
I saw it there lah. I mean, is there a stirrer in the system?
If let's say there's no, then you don't have to,
Oh,
because
yeah,
just
then
now that one was just okay. So this one's not. Can I just remove
sorry.
this?
Yes.
No, it's okay. Because just now the slides that I put up is just for a reference. Because sometimes we may have stirrer to help with mixture or mixing of the fluid. That's where the RPM will come about. Yeah. So state. In fact, if let's say it's not applicable, you don't have to put it there as well. But the state here, yes, because we're talking about steam, means there is a potential of what we want is in gas phase, but
Yes.
what came in was in liquid phase.
Yes.
Yeah. So this shouldn't be slower, but it should be as well as. Yeah, malfunction of heat exchanger, or is that malfunctions of the steam? Because now we are talking about the steam line, that incoming steam line.
So steam station, right? The malfunction.
Yes, is the steam station. Malfunctions of steam station, therefore the steam that's supposed to come in as steam, it comes in steam plus liquid, or is a partial steam, partial liquid. And that can actually destroy our heat exchange function, because we all know that the heat capacity in steam and liquids are very different. So the heat exchange rate in steam and in liquids are very different as well. Yeah, so incomplete reactions causes wastage of solvent use. That is absolutely correct. Yeah, so install temperature sensor to check the state. Yes, you can do that. Anything else?
Possible damage to the, what do you call it? The heat exchanger, because
Yes,
bit
this
of
one
gas
is another
liquid coming in.
possible damage to the heat exchanger. Okay. So I think this is a good one. The install temperature sensor to check the state, because the moment you know the temperature is not 100 degrees Celsius, immediately you want to shut down the system, or immediately you want to do what's that called, a repair, and to quick check of the entire system. Simple, right? Heads up.
Yeah, quite fun.
Heads up is always fun, and sometimes we just have to spend about few hours a day to get a system heads ups sorted out. Because the moment we have this, then you know what to do next. At least you say, you know that, okay, so as an engineer, I need to do this. Especially if you are working, because for chemical engineering, a lot of us will be working in process. And for mechanical, most of us will be working in the maintenance, the servicing department. So this is where you want to look at, okay, so I need a preventive maintenance here. I need to have a checklist. I need to check this one. What do I need to do? How do I want to craft my SOP for my technicians to do that, for example? Yeah. So that's heads ups. Simple. So we have completed for steam. Let's take a look at the volatile. Oh, we have quite a good completion here as well. So let me color code them so that I know which one is which color. So we have flow here, and we have temperature. Okay, so in this case, we only look at 2 today. Okay, ready for this, the team that is working on the solvent streams. Anyone? Hello? Knock, knock. Is there anyone here?
Sorry, this is the CE side, right, Miss?
Yes.
Okay, sorry. We're there.
Yes. And you know what? I always receive feedback from the lecturers saying is that this batch of CE students are very quiet. So can I have someone, please? Anyone? If not, I will just read it on my own. Boo. Anyone? Kelvin, are you here? Because the whole class, I only know Kelvin. And who else?
I'm here, but I'm using phone. I can't see it.
Oh, okay. In that case, never mind. I'll just read it, and then we see how we want to progress from here. Okay, so now we have the solvent streams that talks about the flow rate and also the temperature. So more flow rates, WAF not functioning as usual. Final temperature of solvent is lower than intended. More steam is required for heating. That's a good one. So you have to change the WAF. Yeah, any other things that can prevent this besides changing the valve? If I were to take care of this one, besides changing the valve, I may want to put in the flow rate regulator control system. Meaning, if let's say I notice that the flow rate is too much, I may want that regulator to help me, the control system to help me to regulate it, to open up the valve, to close down the valve to a certain degree so that I can regulate the flow rate. So I would do that if I were to take care of this line. So any other things? If no, then we go to the next one. So less flow rate, partial black pipe blockage, and we have pipe leakage here, yes. So the consequences is that we may have less vaporized solvent, and we have also leaking, solvent leaking, which is very dangerous. So remove blockage by maintenance again, or pipe changes, cleaning. Okay, seal the leakage, replace the pipe. Yes, that's what we are going to do. Any other things? Because that can be man-made as well. Sometimes hazard is not just about the system, but it could be man-made. Like for example, someone accidentally closed the valve or closed that valve to a lower, like what we say just now, earlier, that, what did we use? I remember there was something wrong setting, yes. So it could be, can I just insert one above? Valve at wrong setting. So then we can see what's the consequences that are written there. And then what are we going to do is like checklist, setting checklist.
Can you check the reliability of the
Yes, the liability of the valve. Yes. So meaning we may also need to this one pipe cleaning and then valves maintenance, preventive maintenance.
What about
By the
having
way,
a backup pipes, miss?
backup pipes, it's very difficult for us to have a backup pipes because how many backups do we want? Yeah. So what happened is that if let's say we know that over certain years that the pipes may be blocked, then we want to set a regular maintenance, like to say, oh, every 3 years we will flush the pipes with certain solvent to dissolve all the blockage, those gunk or anything, that the residues of the chemicals in the pipe. Or every few years we will just change all the pipes instead of putting a second pipes there, because the same issues will happen again and again and again. So the more effective way to do is to have a regular maintenance in this case. Do I answer your question?
Yeah.
Okay. So then we have okay. So this one less done, and if let's say we don't have any flow, valve is off, pipe is clogged, so the issue is that there will be no heating of there will be no product. And so this is quite straightforward. Okay. So let's take a look at the temperature here. So if you have more temperature, it's like higher temperature. I wouldn't say more, but I would say higher here. And lower temperature. Higher and lower. So unintended external heating is applied. The cause. How? Anyone help?
From the steam.
But the steam is because now we are talking about the pipes, the incoming. Oh, yes. Okay. The study notes here is solvent streams. You are looking at the incoming or the outgoing? This one, we need to be specific. At incoming or outgoing? So meaning we have two pipes here. Okay, let's go to the other share screen. My application, my windows here. Okay. So which one are you looking at? Are you looking at this one or are you looking at this one? Because these two are two different pipes. This is the incoming, this is the outgoing. So if you are talking about the incoming higher temperatures and what could cause it. But if you are looking at the outgoing, what will cause the outgoing temperature, higher temperature? That then your claim on the other one, then your claim on the this one is applicable, meaning unintended or higher steam that causes the higher temperature. So it really, in this case, you want to justify, you want to make it clear, like you're looking at the incoming piping or are you looking at the outgoing piping temperature? Yeah. So if it's incoming, this is not applicable. If it's outgoing, yes. And so what you want to do, find out the heat source. You know the heat source already. Remove it from a process. If I were you, I would just write refer to the steam Hazard, because we have done that. Yeah. And also at the same time, you again may want to have relief system. Got it? That's
We install a high temperature alarm.
yes, that is detection also. Install high temperature alarm. That's a good one. Okay. So lower temperatures, the unintended cooling, lower temperature, environment temperatures as usual, or it can be the steams piping has issues that causes a lower heat exchange rate, blah, blah, blah. So I believe that this can actually apply. Let's see, source of cooling. Okay, so normally what I would do is straight away this one. And relief system may not be needed in this case because it's lower temperature. So install, I will say you don't need this as well. Yeah. Is that okay? So simple. This hazard analysis is quite
Miss, for the
simple.
high temperature, you can say provide insulation as well.
Yes. This one. High temperature provide insulation?
Yeah, no.
You know what? We also need to have possible, oops, potential insulation layer damage. Meaning, because all this piping, we always have insulation because we are talking about high temperature. So all the steams, they will have their insulation layer. All the chilling waters, they have an insulation layer so that we don't have heat that go off from the piping, that we don't have energy loss within the system. So if that is a insulation layer damage, then our temperatures may not be what we wanted because the heat has lost to the environment. So in that case, then you will also, prevention is to check for insulation damage. and then change it. Yeah.
Okay, miss.
Does it make sense now?
Yeah.
Yeah, so this one can apply for the steam as well. For those who say low temperature, it could be due to low incoming fluid, or it could be damage with insulation layer. Okay. So then you can. So when we do HAZOP, we always go back and forth. If let's say we have an idea here, then we realize, hey, that can be applied in here. That's where we will do that. Any questions regarding how we conduct HAZOPs? Because this is important. Because in your assignment 1, you have to submit a report that has a HAZOP in there as well. And for CE students, your GP2 reports, there is a full sections on HAZOP analysis. So make sure you know what to do. Any questions so far? Class, any questions so far?
Oh, miss.
Okay, good. Or even for your final assessment, since I believe most of you already know that there's no final exam. So 60% will be on a final assessment that will be released in week 12. And then you'll have to submit in week 16 that you have 1 month to do. HAZOP will always be one of the questions. You all can discuss, but please don't copy and paste. So after discussion, then you put in. So I don't mind because I'm going to put out as open-ended. So some of you can work on temperature, some of you can work on pressure. Just don't copy and paste from your friends. Okay? Because the moment you copy and paste, turn it in is going to show up. So you have to write in your own words. Yeah, because HAZOP is required. It's part of the exercise. Yeah? Ken? I've already start giving you
Miss,
tips on how to do it. Yes.
Miss, is there any place we can actually read examples of detection and preventions?
No, it comes with knowledge. It comes with a lot of reading. That is why I asked you. That's where the eight CPD hours is required. That's you read a lot of articles or you attend classes. Because safety is a module that is really open-ended, and a lot of time we say is a module that is talking about common sense. However, sometimes the common sense are not common at all. So this come with a lots of practice. Yeah. That's the fun part as well, because it require you to study. It require you to be creative. It require you to think like one step ahead of others. That's safety. Any other questions?
Miss.
Yes.
Like what if like because there are so many systems, right? Like type of systems in the industry. What we are like, what if like we don't know like some of the system? Then like because we don't know how the system works, so then we cannot perform HAZOP.
Yes. So when we first run HAZOP, you don't perform it on your own. HAZOP is always a group work. So you get someone that is experienced in that area, meaning you can engage consultant. You can get the senior engineers who has worked with the system before as part of your team. So normally HAZOPs will have team of engineers, the process engineer, the service engineer, and in fact, previously when I was working in industry, I always like to engage 1 or 2 operators or their line leader, because they are the one that hands-on. And they are the one who can tell us, oh, this one, when you handle this one, this will be issue. Then you do this. They can tell you a lot of stories that we may not even see it.
Oh, okay.
Yeah.
Makes
So
sense.
when you engage people, that's where okay, that's how things work, and we learn from that.
Okay.
Yeah. So in your final assessment, or even in your assignment 1, please discuss.
Oh, all right.
Please discuss, and then you work it together, and you start to like what I did just now. Like I challenge you all, like, can we do this? Can we do more of this? So have one of the friends to be the bad guy, and start asking questions and start challenging the team. That's where you will get some good analysis out.
All right. Okay, miss. Thanks.
Okay,
Yeah.
so I think we are done with heads up. Okay, let's go to. Okay, hold on. I would want to share the tutorial. Okay. So now, oops, let's get back to this one. So now, again, this is where the fun part is. Okay, how come I cannot do anything here? Okay, now my words is not functioning as usual. Okay. So I'm going to leave some space here so that we can start drawing. Okay, your manufacturing plant has purchased a number of robots to facilitate productions. And so basically is where we reduce manpower and we have increased the usage of all these drones, these robots. And I believe some of you are working on drones and some of you are working on the, those robots for your FYP projects. So if let's say you are now instead of controlling or instead of guiding and leading a team of operators, but you are leading a team of robots, what could be the worst case scenario? I'm needing you to unmute yourself to tell me what are the things that the potential. Come on, guys and girls.
Miss, this
They go out of sync and
Out of sync.
yeah, bang each other or something.
Okay, so accidents occurred. Yep. What else?
Get electric shock.
Electric shock. Electric shock on what? It's like the robots get electric shocks?
Yeah.
So malfunction?
Maybe.
Mm-hmm. What about this one? Touch.
If humans are in the way, they might.
Okay.
If humans are in the proximity of the robots, they might get injured.
Humans injuries. Honestly speaking, do you think if let's say we are surrounded by robots, we'll get injured?
Miss, your sabotage meaning hacking of the
Yeah. Hacking, cybersecurity. Yeah. You know why I want to put this up? Yeah. This is the questions that often if let's say some of you have heard about, oh, now the cybersecurity is so important that we have to look into that, and you know why? Even that applies to military as well. So let me share with you the last year or recent incidents that happens around the world. We all know that US and Iran are not in very friendly terms for a long time. And so they have progressed from unfriendly to having some missiles flying around. And in fact, to the extent that they are not just having missiles flying around, but they also have this what we call a cyber war. Because both parties, they have, how to say, they have huge amount of their drones, their weapons. And so now both parties are hiring hackers to hack into each one of their home security system so that they get control of other people's drone. So sabotage is where, or hacking, or cybersecurity is now a big thing, because no matter how good one party is, the other party can just hack it and take over it. That is in terms of weapon security. About like social security, like our what we have here, our identity. Now we are having all these Zoom classes and all that. There are lots of security breach because people are stealing identity, especially if, let's say, you use certain this what we call this certain facilities to have all this online meeting. People can hack in and see what is your company trade secrets. So, and if, let's say, someone hack into all these small robots that you have, especially if your competitor get to hack into it, what happened? You may just have a whole plants that is producing maybe what you don't want instead of what you want. Yeah. So sabotage, or what we call cybersecurity, is a big issue the moment we want to employ robots. The moment we want to say, oh, we want to go full on automation. Yeah. Any other questions regarding this one?
Nope.
Okay. So any other things beside this four? I think, last time I like to challenge the class. Like, it's easier to give me 3 or 4. I'm throwing the same challenge. Give me 10. What are the 10 hazards? Now we have 4 here. Come on.
Emergency shutdown of the robots if they get out of hand.
Emergency, the hazard? I'm talking about
Oh,
hazards.
you want the hazard? Oh, okay.
Yes, I want the hazards because the moment we have all these hazards, then we know how to counter them. So we are looking at the hazards.
Miss, what if component short circuit?
Yeah, component short circuit. Short circuits. So it's like high maintenance cost. Okay, what else? Hazards. There was one year I actually put this as the final exam questions, and I state there, give me 10 hazards that associates with robots. And it was quite.
If like one robot is down, the whole production line will be affected.
How is that so?
Like, let's say let's say there's production assembly line. So let's say the production line is one of the robots is down, therefore the assembly line cannot function, and therefore the yield cannot, the target amount of products for that day cannot be achieved. So it affects yield. Yeah.
Productivities. Again, this is like out of sync, right? Or
Oh,
productivities, output affected due to what's that called? It's about the same thing.
Downtime.
Downtime. That's a good.
Downline. Yeah.
Okay. Oh, we humans also have this one, right? It's like, even though if you don't supposedly robots will increase productivity or will reduce costs because humans, we have wages and all that. Robots is just one-time payment, and you buy them, you have them, and you can run them for 24 hours. So what are the potentials? What are the things that we have to be careful of? So the biggest things I would say is this one. The biggest hazard is basically this one, the cybersecurity. The rest are just more of like the things that we have to be aware of when we have robots. But what other things?
Miss, what about robots can only work in a certain parameter, whereas humans can adapt? If just say there's such, I mean, there's other situations that come into
So
play.
limited, what is that called? Is that brain activities or limited thought, thinking power? Not able to make, what's that called? Decision.
Yeah, decision outside their scope,
Yes,
the program.
decision out of their scope or programming. Okay, that's a good one because yeah, that is why the latest research now in the market, another research, one is cybersecurity, the other one is what we call machine learning. Have you heard about that words before? It's a new thing. It's like they want the AI to learn something. Like machine learning is very, very fun. Like for example, Google. Google is a very established machine learning server. It's like how they teach Google how to recognize a dog, for example, is that it gave it like tens of thousands of pictures of dogs. So the processors will then learn, okay, this is dog, 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 and then give them tens of thousands things that is not dogs. Give it a duck, give it an elephant, and to tell them this is not dog. So at the end of the day, the moments the dog matches that they call it facial recognitions or signal processing or data processing, the moments they put up the photos, then Google's will then can recognize, hey, this is dog and this is this breed. Nowadays you can put in your photos of your pets and it can tell you what breeds are they. This is all what we call machine learning. It's a cool thing to play with.
Miss, what about mechanical defects, mechanical failures of the robot?
Mechanical defects.
Yeah,
Yeah.
as a hazard.
Yes, possible. Possible. It's like
Okay. Improper installation.
that's a good one. Improper improper installation. That's a good one too. Or what we call the misuse.
So we need another 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, there's 9. Okay, so one more, right?
One more.
Okay.
That's very
Miss, is high cost considered hazard, no, right?
No, high cost is not the hazards, but what are
Okay.
the hazards? Like improper installations will cause the robot to damage certain things. Hazards is where it can put damage to human, it can put damage to your products, it can put damage to the environment, it can put damage to, or it can put a dent to your management's like supposedly you want to buy 10,000 robots to do this, but then because of all the sabotage and the whatever havoc that it creates, that now you have to pay extra. Yeah, high cost is one of, like we already put it here, high maintenance cost is part of the issues, but it's not a hazard.
Miss, what about wrong input parameters?
Oh, that's a good one. Parameters. And you know, another, I wouldn't call that a hazard, but another requirement is that using robots to replace humans makes the qualifications of the humans to control robots increases.
You mean like health hazard of the human? No.
Health hazards not so much, unless your robots, the one that you buy is run by combustions engine that will create more greenhouse effect, then maybe. But if you are getting a robot that is like solar power or something, then it shouldn't be any issues.
Now, Miss, can you say like robots only can handle like certain tasks, right?
Yes.
What if like unexpected situations happen, then they can?
Yeah, so that is where limiting thinking power, that's where we
Oh,
say this, that's where we put it here, where it cannot make decisions. Like when there's an emergency, if let's say there's a fire suddenly, the robots wouldn't know how to handle it because the robot, if let's say the robots you purchase is for productions only, they would not know if let's say there's a fire, what should they do?
They
The
cannot
next,
run.
the next thing is they may just run into the fire and continue to work. You get what I mean here? I guess that's where the hazards come about. Then you have more damage. Yeah, so the limited thinking power, the inability to make decisions, to make judgment. Yeah, there are lots of good things about having robots because you don't have to worry about the company can save a lot of money when they use robots. But one day, because you see, our society compared to when I was at your age, which is like 20 years ago, and today's, things are changing. Things are moving away from manpower. When I was in your age, when I want to get a movie ticket, there's no way that I can purchase online because computer is not even available yet. And the whole household, we share one computer and the computer is huge. We don't even have handphone at that time. And the handphones that was available is the size of the water bottle. So if we want to go to watch movie, we have to go and buy ticket from the counter. So they need manpower to sell tickets. But how many manpowers that we see in the cinema today versus back then? Back then they may have 10 lines, 10 counters, and 10 people selling tickets. Now they only maybe have one there just to make sure everything is going smoothly. The rest, there's screen there, you can touch. Those are robots. Or you can buy online the software and you can buy through it, and then you don't even need to print out the tickets. You just use your phone and you can go in. So we are moving away from a lot of manual working. And in another thing is that the society is changing. And the next thing, we as an engineer, when we design all this robot, we also have to think of what about these people who is going to lose their job? What about all these operators or these people who were once at the counter, who earn their daily earnings at the counters by selling tickets? What are they going to do? That's where, as engineer, we will also have to design how to make sure they are being prepared, to train them up, to train your operator up to certain level of skills, so that when they are being replaced by robot, they are still needed to do something else. Maybe not all of them. You can maybe at one point you have like 50 of the operators. Now you may just keep 10. But they are no longer doing what they used to do, you see. So as engineers, the way that how we operate things is going to change, especially when all of you are in about my age. That times the world will be very different. There are jobs that is not even exist now, may exist during your time. You know. So these are the things that we have to solve before we enter that stage. All these answers here that we are talking about, those hazards. Yeah. Any
Okay.
questions?
No, miss.
So, what are the effective safeguard against this hazard? Simple lah. The moment you can listen down, the moment you know what you can do about that, right?
Yep.
Yeah. So I think we don't need to go through this one. The safeguard. I think if you look back at this, I'm going to post this in Times so that you know these are the answers that we talk about. Then you can start to put in your own input in there to know that, hey, I will do this, I can do this, I can do this, I can do this. Yeah. Okay, so next questions. How much time do we have? It's already 4. Okay, an operator was told to control the temperature of a reactor at 60s. he set the point of temperature controller at 60. And the scale actually indicates 0 to 100 of a temperature range of 0 to 200 degrees Celsius. This causes a runaway reactions that overpressures the vessel. Liquid will discharge and injure the operator. So what is the set point temperatures of the operator actually set? I'm going to draw this. Okay, so this is the indicator. We have it 0 to 100. So what happened is this is 60. So operator set this one.
So he actually set 60% of 200 degrees lah, miss.
Yes. So what is the temperature that he set?
Calculator.
60 times 200, you need to calculate. 60 times 2 is...
120.
So
Just to
it's...
double confirm.
Yes, thank you for the double confirm. Okay, so basically, he set the reactor at 120 degrees Celsius. Of course, that caused a runaway. So if you are the engineer, and then now your boss say, oh, I don't have money to buy a new controller. This is what you have. What are you going to do? The easiest way.
Fire him.
No, you can't fire your boss. Only your boss can fire you, by the way.
Oh, sorry. To him. Okay.
What are you going to do with this system that your boss tell you or the management tell you, we are not going to change the controller. The controller is there. But how do you want to make sure that this is safe?
Maybe just put in the indicator of the percent indicator at each number.
Bingo. You don't have to put in the percent of indicator as each number because you only want 60 degrees Celsius, ma.
Oh, so at just 60 lah.
You just put it here. You ask people, in fact you can use some paper to cover all these numbers so that you don't confuse everyone. And then you just put an indicator, put a sticker, simple sticker here. That's how we engineers work. And tell them here, not here. Not this one. This one. That's it. Sometimes as an engineer, we have to be very creative. Simple.
Yes.
And you don't even need to use money in here. All you need is find one sticker or get a marker pen to make the mark. Okay? Ken? Simple questions.
Okay.
Okay, so... So this is another common sense questions, and this is also a questions that I like to ask in an open book exam. But since we are going to discuss here, maybe you want me to ask this, or I will skip this so that I can keep it as one of my questions. Okay, we are going to discuss this, but bear in mind in your final exam or in your final assessment, questions like this will come out, like asking you like what's going on, what went wrong. Okay, liquid level in a storage tank are normally determined by measuring the pressures at the bottom of the tank. So basically you have this tank here, then you have this sensor here. So we want to know what is the height of this tank. So the sensor here is to measure the pressure. And one day we change the material. We change this material into this one. And so then the storage tank was overflow. Why? What causes that overflow?
The different material probably has a different density.
Yes, you got it. That's the answer. Density change. So, if you're the engineer, what are you going to do with this?
Probably ensure that the method of measuring pressure is based on types of densities of material to be stored.
So meaning you need to do a recalculation.
Yes.
And then I suggest you put up the calibration
Yes. So,
table, so that when people know that they use material A, they need to use this. They use material B, they need to use this. Because when you calibrate, then you calibrate the pressures to tell you the right things, how it measures. Because then it will then measure this at a different pressure. Yeah. Or if let's say it's as a simple way to do things, what are you going to do if you are engineers giving a little bit of budget here?
yes. Okay, Miss.
What do you want to do?
To do for what? Sorry, Miss.
If let's say you are given the budget to prevent this from happening, what are you going to do?
Install an automated pressure detection system.
Why still pressure detection system? You are talking about liquid level, man.
Oh,
Volume.
volume. Sorry,
You're
volume
talking about
detection
liquid
system.
level. So you want the level controller. You want the liquid level detection.
Oh,
So
I thought
you do
still want a based of pressure. Okay, my bad.
no. Engineers, we have to think out of the box. So you change what we call change to level control system. That's one. Okay, this is one way you can do it. To prevent it, another way I'm going to do it if I were the one that I'm going to open up a pipe here and bring this to a second storage tank. So in the event and put a sensor here. So the moment there's liquid coming down, it will trigger the sensor. Then I know it's overflowing. And with these sensors, if let's say there's a waft, coming in here, this waft, you can actually use this to close the waft. Can? And you know you won't waste chemical because whatever go to the storage is still in your storage system. You won't have that overflow. But at the same time, you have a safeguard here. So the moment there's liquid coming in here, your sensor get triggers, you close the valve. That's another way to do that. But the easiest way, of course, this one. Okay? Can?
Okay. Okay.
Simple. Very simple. Okay, so oops, we are talking about keys here. Now you know what keys is for. So we have a system here, and we also talk about when we come to safety, we want to keep things really, really straightforward and simple. Okay, so you look at this one, you have a sump here to collect processed fluid, you have a controller, and you have the pump to ensure that the sump is maintained below a maximum height. So how do you want to make this system simpler? I've given you the answer previously.
Overflow valve.
Yeah, no, I'm just going to remove that whole system. Again, I put up a pipe here. Oh, okay, can't really draw correctly here. Okay, let's draw it correctly. Come on. Open out a piping here. And then to wherever storage. It's as simple as that. You don't need this pump. You don't need this level controller. You don't need all this. All you need is to open it at the level, maximum level that you know that it will go overflow, and then to a place that you want it to store. Simple. You don't have to do pump maintenance. You don't have to do controller maintenance. You don't have to do valve maintenance in this case. Got it? Hello?
Yes, Miss. Yes, Miss. Yes, Miss.
Okay.
Correct.
Done. So we are done with this whole experiment. Oh,
Miss,
not experiment.
just a
Yes.
question regarding the assignment.
Yes.
Okay, that time you said there is HAZOP analysis,
Yes.
but in the rubrics I don't see. Is it? It's under which part? Huh?
It's where you do the analysis. Okay, hold on. Did I change your assignments? Yes, I did change your assignment a bit. So on the suggestions of like how you want to prevent it, let me go back to look at the assignments. Hold on. Oh no.
Because I was looking at the rubric and then I didn't remember seeing heads-up analysis. That's why.
You can choose heads-up, you can choose LOPA, you can choose inventory or fault tree. So I didn't put in as heads-up as the requirement, but it's part of that.
Is it the risk assessment part? Is it the
Yes.
methodology?
Yes.
Okay.
Yes, that part.
Understand.
Hold on, let me open up and see. So can you see this? Are you seeing the case study?
Not yet.
Okay, meaning I have to close the sharing and then I have to reshare it. Okay, so application windows. Oh yes, I have to reshare this. Okay, so this is the case study that I gave to you all, right?
Yes.
So these are all the titles and then the reports, methodology, the result and discussion. So that is where you want to compare it. And yes, here, this part, the risk
Okay.
assessment, because you want to see how you assess it. The way that you assess it, you can use heads-up, you can use LOPA system, layer of protections analysis. You can use FMEA. You can use or you can, most of the time that we will start with a fishbone diagram first to address the 4M. Then after that, we zoom into each one of it. So you can use event tree and fault tree analysis, which we are going to cover in the chapter later. But you can refer to the slides first.
But Miss, if I just use heads-up, it's fine, right? It's still
Yes,
applicable.
of
Okay.
course.
All right.
Of course, it's always applicable. That's why in safety, what I'm teaching all of you here is the tools, different type of tools. You can use this, you can use this, you can use this to calculate certain things or to assess certain things.
Okay.
Yeah. So later, I think in another 2 weeks' time, I'm going to share on the event tree and fault tree analysis. That's also you can use. That's very simple, but that one you may need to get some data because you need to know what is the faulty rate of each of the elements that you look at.
Okay.
Okay.
But if I just use one method is fine. It's just enough, right?
Yes, of course. One
Okay.
will
Thank you
do.
so much. Thank you so much.
Don't
Okay.
overdo things.
Okay.
Okay.
Thank you.
Yeah. Any other questions so far? I think we are done with today's tutorial because there's only these 5 questions. Yes, that's it. We are done with today's tutorial. Any
Alright,
other
miss.
questions? Any things that you want to ask me about your final exam, final assessments, or anything?
So
Oh,
far,
I
all
just
good.
saw someone right there, overheating of robot. That is a very good one. Sorry, earlier on I didn't see that. Let me put that back. Let me put that important parts in. Overheating of robots. Later, I'm going to share this discussion today on Times so that you can take a look at what we have talked about. Okay, so your final assessment questions will be very similar to what we do today.
Okay.
So meaning it requires you to think. You can discuss, as I said, but do not copy. Please don't just copy and paste because I really hate it when students do copy and paste and think that I don't know how to read.
Yes.
So please
Okay.
don't do that to me. Okay. So you can write it in your own words. You can do it, write it in point forms, or you can write it in a table forms or how you want to present it. But write it in your own words, please. Okay.
Alright,
The
miss.
questions will be very similar that require you to think. It's an open book, so and also it's an open source, meaning you can try to find your answers in the internet. You can try to discuss with your friends, and then you write your own reports. Yeah, or you write your own. The final reports will be like 8 to 10 pages. I'm going to limit it to 10 or 12 pages maximum because don't write too much, even though it's 60%, because what I want is the essence of how you do it. Okay.
Alright, miss.
Okay,
Good.
Miss.
Good, good. So if there's no questions, then I'll see you all next week because next week we are going to have a tutorial on the calculations on fire and explosion. Because this week I cover fire, next week I'm going to cover explosion. Then we can have a tutorial how to do that.
All right. Thanks.
Okay, I see you all next week then. Bye bye. Do you all want to do it the same time or do you all want to split classes?
Same time is fine with me.
This one,
Yeah.
because I know ME students, your tutorial is these slots. But for
Yes.
CE students, anyone from CE, do you all have class at this slot?
Yeah, we have actually.
Okay, so then I will have one class on Thursday. I will have another class on Friday because the next week classes is not so much of discussion like what we did today. So it's more on like how to solve those calculations. So then I can have split classes. Okay.
Okay.
Alright.
So we
Can
have one on Thursday, one on Friday. It's the same class, so you can choose whether you want to attend the Thursday or the Friday classes. If let's say you can't attend both, it's okay because it will be recorded, so I'm going to post it up.
Okay.
Did I
Can.
manage to really record everything? Hold on. It was recorded, right?
It shows. Yeah, it shows here 2 hours 20
Okay.
minutes recording. Yes.
Miss,
Yes.
for the assignment, right, the reference, how many do you want?
You can put in as many as you want. Because I'm not
Is-
going to count on the references, like how many reference you put in. But
Oh, okay.
as long as you put it inside your assignment or your reports, remember, because to avoid plagiarisms,
Mm.
it's always good to cite them.
All right.
Yeah, so just cite it. It's okay. But for safety reports, right, you can cite internet sources or anything. It's different from your FYP report. Your FYP report, you cannot cite internet resources.
Yeah.
Yeah, you know that,
Yeah.
right? But for safety, yes, you can cite internet reference because that's how you get your knowledge.
Okay.
Just one thing that don't cite Wikipedia.
Yeah, definitely not. Thanks.
You know why? Because you and I can change that.
Okay, Miss.
Yeah, so don't cite Wikipedia. The rest you can cite. Okay, I think that's it for today's. Thank you for being here, and I'll see you all next week then. Bye
Okay, Miss.
bye.
Thank you. Bye bye.